All right, guys, review day. We're just going to go through the test questions or the test review questions one at a time, give you kind of a basic idea of how to solve it. I'm not going to go into a lot of detail. I've already taught you how to do these things. I'm just going to go through the solution kind of quickly so you can see what it looks like. I would prefer that you're using the video rather than the Get Help Me button to guide you through these. I'll show you the easiest solution for each situation, give you some tips that way rather than trying to sort through what the Get Help button recommends for you. So problem number one, solve the formula for the indicated variable. Remember, when you're solving for a variable, it means you're trying to get that C by itself. So I've got to get rid of this A and this B. And right now they're being multiplied by C. So to get rid of A and B, I'm going to divide by A and B, which means on this side I have to divide by A and B. So D divided by A and B is equal to C. And that's it. That's your final answer. Make sure if it's a capital letter that in the solution, when you're typing in your answer, that you capitalize it. If you put a lowercase d or a lowercase c, it's going to count it wrong because it is wrong. An uppercase C is different than a lowercase. All right, number two, solve the equation for u. U times k plus u times n equals x. And for this one, remember how we talked about 5u plus 6u. The way we solve that is we take the 5 and the 6 and we add them together, and that's how many u's that we have. In this case, we have k u's and we have an n number of u's. So k plus n, if I add the k and the n together, that's how many u's I have. That equals x. So to get rid of k plus n, I divide by k plus n on both sides. So u is equal to x over k plus n on the bottom. Again, be careful of your capitalized letters. In this case, they should all be lowercase, but that would be your final answer. All right, number three. For whatever reason, this has been causing some grief, and I think it's just because there's a lot of words and you stop reading it. All this is saying is it gives you a formula, D equals R times T, and especially if you've taken driver's ed, it's saying that the distance you drive is equal to how fast you're going multiplied by how long you're driving. In other words, if I'm going 50 miles an hour for 3 hours, I times those together and I've gone 150 miles. So distance is represented by D, the rate is R, and time is T. Part A just wants you, if you're going 51 miles per hour, so that's my R. For 5.5 hours, that's my T. How far am I going to go? So what's the D equal? So D equals 51 multiplied by 5.5. And that's all I have to do is multiply those together. So if you go to your, you can do it however you want. You can do 51 times 5.5 and you get 280.5. 280.5. That's your distance. So that would be part A. Part B is where people have gotten a little bit confused. Solve the formula for T. D equals R times T. It wants us to solve it for T. That doesn't mean there's no numbers involved. I'm solving this formula for the letter T. So all I have to do is get T by itself by dividing by R. So distance divided by speed equals time. And that would be part B. That's your part B. There's your part A. Okay, number four. These are really the freebies on the test. At this point, the first 5 especially, maybe even 6, should just be freebie questions for you. As long as you've seen them, as long as you've reviewed them, I think you'll be okay. This one wants us to solve for n. So n is what I'm trying to get by itself. So I'm going to minus y from both sides. So capital C minus y equals qn, and then I divide by q. So capital C minus y divided by q is equal to n. Once again, if you do not put a capital C, it's going to count that one wrong. Okay, number 5. 3x plus y equals 10. and y equals 2x. It wants us to solve using substitution. So I take this y and I plug it in for that y right there. So 3x plus 2x equals 10, which means that 5x equals 10. And when I divide both sides by 5, x is equal to 2. I'm not quite done because I also need a y value. So once I know my x, remember, just plug it in right there for x and figure out what y is. So y equals 2 times x, which is 2 times 2, which is 4. So x equals 2, y equals 4. I'm going to put that in as an ordered pair because it is a point on the graph. So parenthesis 2 comma 4. All right, number 6, solve the system by elimination. X plus y equals -7, x minus y equals -1. Elimination, remember, we can either add these together because the x's are the same, and the y's happen to be the same. So I can take this entire equation and I can add it to the second equation because my x's and my y's are the same. In this case, we can add or subtract. If I add, my y's are going to go away if I subtract x's. So I'm going to go ahead and add. X plus x is 2x. Y plus a negative y is 0. So those cancel out. And then -7 plus -1 is -8. So 2x equals -8. If I divide both sides by 2, x is equal to -4. All right, number 7. Solve by the elimination method. 2x minus 7y equals -21. 7x plus 2y equals 59. The problem with eliminating this time is that my x's don't match and my y's don't match. So in order to make them match, I've got to change the equations. I've got to multiply both of them in this case. So the top one, I'm going to go ahead and multiply by 2. And the bottom one, I'm going to multiply by 7. Everything in that equation. And I'm going to do that because I want to turn this into 14 and I want to turn this into 14. So when I add them together, they go away. So multiply everything by 2. 2 times 2x is 4x. 2 times -7 is -14y. 2 times -21 is -42. And on the second one, 7 times 7x is 49x's. 7 times positive 2y is positive 14y. And 7 times 59 is going to be 350 minus 7. Nope, 420 minus 7. So 413. Because 7 times 60 is 420, but it's not 60, it's 59. So 413. Then I just add these equations together because I want these y's to go away. And since this is a negative, this is a positive, if I add them, those y's add up to 0. 4 plus 49 is 53x. And -42 plus 413 is going to be 371. Now to get rid of this, I have 53x equals 371. I want to get rid of that 53. So I divide both sides by 53. So x equals 371 divided by 53 is going to be 7. So my x value is 7. And now I just plug it into one of my original equations. So 7, I'm going to use this equation right here. 7 times 7 plus 2 times y equals 59. 7 times 7 is 49 plus 2 times y equals 59. Minus 49 from both sides. So 2y equals 10. Divide by 5, or divide by 5. Divide by 2, y equals 5. So x is 7, y is 5. So my answer is 7, 5. All right, number 8. Solve the following system by using substitution. Y equals x squared minus 4x minus 5, and y equals 2x plus 11. They both are equal to y, which means they equal each other. So x squared minus 4x minus 5 is equal to this one, 2x plus 11. Now, if you remember the steps to solving these x squared ones, I want to get rid of, I want to move everything to one side. So I'm going to minus 2x from both sides. And I'm also going to minus 11. And I hope you're okay that I'm doing that at the same time. So x squared minus 6x, negative 5 minus 11, negative 16 equals 0. Now, if I'm going too fast, pause the video, write down what I wrote, replay it. I know I'm kind of going quickly through the questions, but we have a lot to cover. So now I'm looking for factors of negative 16 that can add up to 6. 1 and 16 aren't going to work. 2 and 8, since they multiply to be a negative, one of them needs to be negative. And since they add up to negative 6, negative 8 is going to be what I want. So x minus 8 and x plus 2. Those multiply to negative 16. Negative 8 plus 2 is negative 6. So those equal 0. Our next step was to set our parentheses x to equal 0. So x minus 8 equals 0. So when I add 8 to both sides, x equals 8. X plus 2 equals 0. So when I minus 2 from both sides, x equals negative 2. So there's my two x's. I'm going to plug them into this equation to figure out my y. So y equals 2 times 8 plus 11, and y equals 2 times negative 2 plus 11. So 16 plus 11, y equals 27, and negative 4 plus 11, y equals positive 7, excuse me. So when x is 8, y is 27. There's my first answer, and I need to be careful that I put a comma in between my second answer, which is negative 2 and 7. Don't forget that comma, or the computer is going to think that you got the answer wrong. All right, number 9. Solve the following system by graphing. So x squared plus 2x plus 6 and negative x plus 4. It wants us to graph, which technically we could solve all of these by graphing, but let's go ahead and do that. So x squared plus 2x plus 6. Did I copy that down right? X squared plus 2x plus 6. And then negative x plus 4. So then my next equation is going to be negative x plus 4. Please don't put minus x plus 4 or it'll give you a syntax error. I want to do a standard zoom. So when I graph this, there's my parabola. And there is my intersections. And it looks like it crosses right here. And then it goes inside my parabola and comes out the other side. So there are, in fact, two solutions. So when I calculate those, remember to do that, you do second, hit the trace button, and we want to choose the intersection. We want to find where y1, enter, and y2, where the blue and the red one, we want to find where they cross. And at my third time, it's going to ask me to guess. And because there's two answers, remember, you have to get both answers. So I'm going to guess this one first. I'm going to move my cursor close to that answer and hit enter. And it tells me that one of my answers, x is negative 1 and y equals 5. So one of my answers is negative 1 comma 5. But I have another answer that I need to find. So I do second trace again, choose intersection. This time I hit enter twice, but when I guess, I want it to pick up this solution. So I need to scroll over closer to that one. And when I guess, x equals negative 2 and y equals 6. So my other answer is negative 2 comma 6. It gives you that information down there at the bottom. So there's your solutions. Again, you can do that process with any of these. On any of these problems, you can graph them. As long as you set them y equals, you can get the solution that way. Number 10, x squared plus y squared equals 100. This defines a circle with center at origin and radius 10. The line y equals x plus 2 passes through the circle. So I have two equations, x squared plus y squared equals 100. And y equals x plus 2. There's a couple of ways to do this, and I'm gonna show you both. The first one is mathematically. I take this y equals and I plug it in for my y value right there. So I get x squared plus, instead of a y, I'm going to put x plus 2, but that needs to be squared, and that equals 100. We need to be careful right here because x plus 2 squared means x plus 2 multiplied by x plus 2. So we need to remember to FOIL this right here. So I have an x squared. X times x is another x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. And those equal 100. So like terms, 2x squared plus 4x plus 4 equals 100. I want to get everything on one side. So I'm going to minus 100, minus 100. 2x squared plus 4x minus 96 equals 0. Now here's where we can simplify this problem a little bit. X squared is being multiplied by 2. And before I factor this, I want to get rid of that 2. And the way I'm going to do that is I'm going to divide everything on this side by 2, which means I also have to divide everything on this side by 2. And I do that, well, let me show you. 2x squared divided by 2 becomes x squared. 4x divided by 2 just becomes 2x. Negative 96 divided by 2 becomes negative 48. But here's the cool part. 0 divided by 2 is just 0. So by dividing everything by 2, I just made my factoring a whole bunch easier. I'm looking for something that multiplies to negative 48 and adds up to 2. So there's 12 and 4. Those aren't going to work. 2 and 24 definitely won't work. 8 and 6, I believe, multiply to be 48. But one of them needs to be a negative. And because this is a positive 2x, I want the smaller number to be the negative. So when I factor, I get x plus 8 multiplied by x minus 6 equaling 0. So now that they're both equal to 0, I can set these each equal to 0. Or I can just do the shortcut. X plus 8 means that x is negative 8. X minus 6 means that x is positive 6. Remember, you take the opposite, and that's what x is equal. So I have my two x values. All I have to do is plug them in to this equation, y equals x plus 2, to get my y values. So y equals negative 8 plus 2, which equals negative 6. So when x is negative 8, y is negative 6. There's one of my answers. And then y equals x plus 2. I'm going to plug in a 6. 6 plus 2. So y equals 8. So when x is 6, y is 8. There's your second answer. Okay. The other way to solve this is by graphing it. But you have to be really careful. And I hesitate to show you this a little bit. If you like what we just did, if you like the mathematical way, go ahead and use it. The other way to do this, you have to be careful a little bit. One of our equations is already y equals x plus 2. But this one, x squared plus y squared equals 100. To solve for y, I have to minus x squared. So y squared equals 100 minus x squared. And here's where we need to be careful. To get rid of the squared, I square root both sides. So y equals the square root of 100 minus x squared. But remember, when we square root something, there's a positive and a negative answer. So y also equals negative square root 100 minus x squared. So I don't just have 2y equals, I have 3y equals. So when I graph this, my y1, I'm going to set that to be the second square root of 100 minus x squared. Oh, let's clear that because I have a whole bunch of stuff in the way. Second square root 100 minus x squared. My second line is going to be the negative square root of 100 minus x squared. And then my third line was y equals x plus 2. So x plus 2. And when I graph these, look at what we see. There's the first line. There's half of my circle. To get the other half of the circle, we needed that second line. And then our third one is that straight line that's going to cross. So here's where we need to be careful. When I go to second calculate intersections, I need to be careful because this intersection is on the blue line, which is my y1. So I can hit enter. But my other intersection is this intersection. The other line it crosses with is y3, the black one. So I don't want to hit enter again until I select that line. And when I guess, I'm going to move over here to the right just a little bit so that it guesses the right one. So my intersection for this point is 6, 8. So my answer, 6, 8, which matches this answer right here. The other intersection, when I go to second calculate intersection, I don't want to select the blue anymore because my intersection's down here, which is part of the red graph. So I hit enter for y2, enter for y3. And then when I guess, it's important that I move my cursor all the way across. Let's see, well, let me hold it down. There we go. It's important that I move it down here so that I'm guessing close to the right intersection. And it tells me that that one is -8, -6. So they both require some math. The first way requires a whole bunch of steps. You have to FOIL, combine like terms, get rid of this 2 factor, plug in your answers. This way, all you have to do is minus the x squared and remember that you have not just one line or 2 lines, but there's actually 3 graphs that you're dealing with. So if you use the graphing method, which is definitely shorter and easier, be careful that you don't forget that negative square root. All right, number 11. Now this one can either be the hardest or the easiest question on the test. Okay, maybe not the easiest, but one of the easier ones. And that's because we are going to solve by graphing. The mathematical way is great, but it's a really long process and it makes this a 10-minute question. We're going to graph this one, which means that x times y equals 20. I've got to get y by itself. So I divide by x. So y is equal to 20 divided by x. There's one of, that's not a solution, but that's one of my graphs. The other one, 2x minus y equals -6. I need to solve for y. First thing I'm going to do is add y to both sides because I don't want a negative y. So I'm going to move it over, and then I'm going to move the 6 over to the left. So I get 2x plus 6 equals y. So there's my second graph that I need. So 2x plus 6 and 20 divided by x. Now when I graph these, let's go ahead and get rid of this extra stuff. We had 2x plus 6, I think, or did I forget already? 2x plus 6 equals y, and then 20 divided by x. So 2x plus 6, there's my first one. 20 divided by x, there's my second one. When I graph this, it's going to look different than something you've seen. There's my line, but look at my second graph. Part of it's over here, and the other part shows up on the right. If I zoom out a little bit, just to show you what's happening, I've got my line, and even though this looks like it's 2 different graphs because part of it's over here and part of it's over here, remember that x can't equal 0 when you're doing 20 divided by x. If my graph, if y equals 20 over x, all of these points on the graph work except for when x is 0 because that doesn't exist. And that's why this red graph comes over and it gets really close to 0, but it never actually reaches 0. And so when we go to the other side of the 0 point, we're on the right. And as I get bigger, I go to the right. So it is one graph. It's just split into two parts. So let's go ahead and trace, second trace. Let's find the intersections. So Y1, I hit enter. Y2, I'm going to just move my cursor over here to the left so that I know it's looking over here. And then I'm going to guess. And again, I want to guess this intersection right here, not this one. I want to guess this one. So when I hit enter, it tells me that one of my answers is -5, -4. So one of my solutions, -5, -4. My other solution, I'm going to second trace, calculate the intersection. I want Y1. And again, I want my Y2 graph. But I'm going to just make sure I select on this side. So Y2. And then when I guess, I'm going to guess near this intersection because that's the one that I'm looking for. So X equals 2, Y equals 10. So my other solution is 2, 10. So that really long 10-minute problem really can be done in about 2 minutes. Solve for Y, put them in the calculator, graph the picture, and let it find the intersections for you. Okay, number 12. We've got 4 more problems. Solve the inequality, graph the solution. 5 times n minus 7 plus 3 is less than 8. A lot of you aren't going to be happy that I'm not distributing the 5, but I don't need to. I can just minus 3 from both sides and get 5 times m minus 7 is less than 5. 5 is being multiplied by these parentheses. So I'm going to divide both sides by 5, and I'm left with m minus 7 is less than 1. So when I add 8 to both sides, m is less than, or add 8. Wow, where did that come from? When I add 7 to both sides, I'm like working ahead here. When I add 7 to both sides, m is less than 8. 1 plus 7 is 8. Sorry, that's m minus 7 is less than 1. Add 7 to both sides, m is less than 8. So that would be your solution, but it wants you to also graph it. The good thing is you won't have to actually graph it. You just have to pick the correct graph. M is less than 8, so it's an open circle on 8. And since it's less than, it's all the numbers pointing this way. Okay, 13. Not a difficult mathematically, it's just setting up the problem. Oscar and Julie are celebrating their 15th anniversary. They budgeted $2,500. That right there, budgeted $2,500, means that they have to spend less than or equal to $2,500. They can't spend more than that. If the reception hall charges a $50 cleanup fee, so they charge $50 and $34 per person, so 34x. Find the greatest number of people that they may invite. So $50 plus $34 per person is less than or equal to $2,500. So I'm going to minus 50 from both sides. So 34x is less than or equal to 2,450. And then when I divide by 34 to get x alone, x has to be less than or equal to 2,450 divided by 34. And I get 72.0588, blah, 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 blah. This should be the only decimal you get all day. So what was it? 72.05. 72.058, something, something, something. So x has to be less than 72.05. And if these are people that we're talking about, the most amount of people that they can invite is 72, because we have to be less than 72.058. So that's the greatest number that we can invite. Okay, 14. Solve the following compound inequality. The key word for this one is the word and. 4x is greater than or equal to -20. Well, that just, I divide both sides by 4, and x is greater than or equal to -5. And 7x is less than or equal to 14. So I divide both sides by 7, and x is less than or equal to 2. This and word means that X is in between these two numbers, okay? And means that it's in between. So -5 is less than X, but X is less than 2. So when you write your answer, X is in the middle of -5 and 2. So that would be your answer. And then when you graph it, 0, 2, -5, we put a closed circle at 2 and a closed circle at -5. And because it has to satisfy both of these, X is in between -5 and 2, which means X is all of these numbers that connect these 2 points. So if you have a problem with and in it, X is in the middle. You're going to put X in the middle, and your graph is going to connect the 2 dots. Those are the 2 big things that you need to remember about the word and. Because on number 15, there's a different word, a word or. In this case, you divide 7 on both sides. So X is less than or equal to -4. Or when I divide this by 5, X is greater than or equal to 6. The word or doesn't let me connect these into one inequality. This right here is my answer, right there. X is less than or equal to -4, or X is greater than or equal to 6. And what that looks like when we graph it for part 2, there's a closed circle on 6. There's a closed circle at -4. But instead of connecting the dots, my graph points out because X is less than all the -4s, or it's less than or equal, is all the numbers less than or equal to -4, and X is greater than or equal to 6. So if it's an or, your arrows point out. If it's an and, they're connected. And it's important that you remember the difference. It's going to give you both options. Make sure you select the right one for the right problem. Okay, and that's your review. If you have any questions, I'm out of town on Tuesday. I won't be here at the school, but you're more than welcome to email me. Let me know that you're having a problem, or I will be here Wednesday morning before the test. So come see me. I'll do what I can to help you out. Good luck.